We present CloudTrack, a novel approach for semantically conditioned open vocabulary object tracking. In search and rescue scenarios, every second counts. Unmanned aerial vehicles already gather vast amounts of information in the search area. The extent of this data, however, can quickly overwhelm human supervisors. In this setting, AI can make the difference. Often, we search for a person given a verbal description of its state of health, clothing, or other personal attributes. Traditional convolutional neural networks can already detect objects directly on the UAV. Commonly, however, they are limited to a closed set of object classes. They can further not identify semantically more complex scenarios without retraining. As such, they cannot make use of descriptions as the one shown below. In this example, we search for a person who might be unconscious due to a heart condition. With CloudTrack, on the other hand, we can accurately detect a match with a verbal description even from a greater distance. Based on a match, the UAV tracks the object. It can then close the distance and await feedback from a human operator. To achieve this, we combine powerful foundation models in a cloud backend with a lightweight, real-time capable tracker deployed directly on the UAV's companion computer. When launching a search and rescue mission, the operators first define a prompt describing the missing person and an object class. The object class is a one-word description of the object we are searching for. In our case, the class is person. Since the pipeline is built in a fully open vocabulary manner, we can also search for other classes such as vehicles or boats in case of naval accidents. The UAV then takes off and records images with its onboard camera sensor. Until we find a person, all images are sent to the backend for processing. There, an open vocabulary object detector identifies people in the image and returns a bounding box for every match. We then crop each bounding box and send the image patch to a vision language model for fine-grained semantic classification. The vision language model later confirms or rejects a match with the prompt and delivers a justification. We then initialize an object tracker deployed directly on the UAV's companion computer with the bounding box coordinates. The object tracker tracks the bounding box across succeeding frames until the object is either lost or a human operator confirms or rejects the match. We test our system on two publicly available benchmarks against several baseline methods. On the SART dataset, we test our backend's ability of identifying people based on pose, color of clothing, and the need for help. We exceed the best baseline by 19.2% in terms of MAP. We further test 6 different front-end trackers on common drone onboard computers on the referring visual object tracking benchmark. Our best configuration achieves a tracking frame rate of 29 frames per second on a Raspberry Pi 4 and 66 frames per second on a Jetson Orin NX. To summarize, we propose a novel method for semantically conditioned open vocabulary object tracking. Further, through extensive evaluation, we demonstrate the applicability of our method in real-world use cases. Thank you very much.